All right. Hello, everyone. I'm not going to use the mic unless somebody says I really need it. Do I really need it? Oh, okay. Cool. Got that covered. Sorry, bad joke. All right. So I'm going to be speaking today about mastering constraint layouts in Android. So for those of you who don't know me, I'm Rebecca Franks, and I'm an Android developer at DBT, and I'm also a Google Developer Expert for Android. And you can find me on Twitter at Rigaroo, and tweet me things, tell me I'm wrong, tell me I'm right, anything you can imagine, just tweet me. And yeah, I just want to get an understanding of the audience before I sort of dive into constraint layout. So who here is an Android developer by trade? Every day. Okay. Who's written a Hello World Android app? Okay, most people. Okay, cool. And dived into constraint layout at all? Okay, a few people. Cool. So I'm going to show you why I really, really like constraint layout and why I think it's going to be the future going forward in terms of developing layouts for Android. So this is typically what you would create when you were trying to make a layout without using constraint layout. So you can see there's a lot going on in terms of having relative layouts, nesting, there's a linear layout within, just to create this sort of simple looking layout that has like a few things aligned to one another and sort of automatically sizes based on the screen size. So you can see it's a lot of different layouts that you need to include within your layout file, and a lot of it is just sort of positioning information, and it's not actually core to what the screen contains. So hopefully by the end of the session, you'll really, really like using constraint layout and go and try it out in your own apps. So some of the problems with doing standard layouts like what we've seen is that views are used using layout elements. So we have relative layouts, we have linear layouts, we have all these sort of other components that describe exactly where something is positioned on the screen, which is actually quite counterintuitive to what a layout should be. A layout should just contain the views that it needs, and positioning information should either be on the elements itself or within some kind of constraint system that you have on the views themselves. It can also be quite tricky to customize. So if anyone's tried to sort of do really complicated alignment of UI work, it can be really, really difficult, and you'd end up with a really large amount of nesting within your app. And then also, because you're doing this kind of nesting work, you have a really, really poor performance in terms of how your app behaves. So as soon as you start to nest layouts within layouts, your device starts getting slower and slower to render. And then another big one is that animations are really, really tricky in Android. So if anyone's tried to animate something, you'll agree with me on this, that it takes quite a lot of work just to try and do a simple animation of moving something from one side of the screen to the other. So constraint layout solves a lot of these problems, and I think going forward it will be solving a lot more of these problems as well. Okay, so we're going to take a little step back first just to understand how a view is drawn on the screen within Android. So in Android there's a four-part process that needs to happen in order to render a layout on the screen. So it uses a depth-first traversal algorithm to inflate and lay out the elements and how it goes about using and drawing them. So the first phase is inflation. So it takes every single element in your tree, your view tree, and it inflates it, and the next step is measurements. So then it goes and says the parent will measure each child, and the child calculates its measured width and height. Okay? And then it will measure its own children. So that's using obviously the depth-first traversal algorithm. Then the next step is that it'll actually go and it'll size and position the child. So every parent will go and say, for all my children in my view, I need to go and size it and lay it out on the screen. And then what happens is the draw phase. So this is actually when it gets rendered on the screen. So the parent then knows exactly where and how big the elements on the screen should be. And then it goes and tells each single child where exactly to draw and how to draw it. Okay. So if you've done any kind of Android development, you might have run into these layouts. I'll run through them a bit quickly, but you've probably used a linear layout if you've done any Android development. And this basically aligns elements in a single direction. So in this case, You can either do horizontal or vertical, and everything is positioned one after the other. You can also use weights with the linear layout, but please don't do that. Rather use constraint layout because it's a lot less performant to use linear layouts. And yeah, basically it's very simple. You just put elements in and you get a straight linear layout. Okay, so relative layout is probably sort of, I would say, a slimmed down version of constraint layouts, where relative layout allows you to position things relative to one another. So in this case, I can position something above something else, or at the bottom of the screen, or to the left, to the right of something. So this is sort of the step one of constraint layout. And it's a very powerful layout as well. The problem with relative layout is that it needs to do 2 layout passes. So that diagram that we saw earlier of how a view is drawn on the screen, it needs to do that twice in order to know exactly where to place something and put it on the screen. So it's not as good for performance as, for instance, constraint layout. Okay, and then an interesting one, which is probably the simplest, is a frame layout. So that allows you to just have one single view in the screen. And this one is typically used for hiding or showing error layouts, or doing like a sort of overlay on top of a map. You would use maybe a frame layout to do that. And this is drawn in a stack from most recent to whatever, on top of one another. And with this one, this was actually quite a powerful one, and it's used with fragments as well. So these are still used when using constraint layout, but yeah, you can see where to use constraint layout versus when to use what. Cool, so on to the good stuff. So constraint layouts. So constraint layout, this is the layout that we saw previously, where we had all these different views inside with their positioning information. But now with constraint layout, you can just slim that down just to the views that you need within the layout. And on those views themselves, the positioning information will be on those views. And if you've tried doing any sort of UI work within the layout editor on Android Studio, you would have probably run into problems where it just doesn't look right. I mean, if anyone's used linear layouts or something like that, you've probably not wanted to use the layout editor at all. So I'm hoping to change that perception today, because a lot of the improvements in the layout editor have come in sort of Android Studio 3, and this layout editor for constraint layout has been rewritten from the ground up just to encompass all these constraints and just to be a really powerful editor. So what it amazed me was I tried to rebuild this Google Play movie screen, and I was able to get this rendering in Android Studio, which is quite a feat if anyone's done any sort of layout work in Android. Okay, so background information on constraint layout. It was released at Google I/O 2016, so it's been going for a while now. And there was initially, when I tried it out, there were quite a few bugs with it, but there's a lot of improvements lately, and it's really got a lot more features as well. And it also supports API level 9 and plus. So I think that's Gingerbread. I'm not sure. It's really old. So you can guarantee that it'll run on most of the devices that you use today. The interesting part is that it's not bundled with the Android SDK. So you would just include it as a dependency within your Gradle file to include the constraint layout dependency. So actually, yesterday was a release of beta 2 for constraint layout with a bunch of bug fixes as well. So I had to update my slides yesterday. Luckily, I saw it. But yeah, so beta 2 now has a whole bunch more features that just the stable version of constraint layout doesn't have. So if you've used Android Studio 2.3, you might not see some of the features that I'm going to show you today because you're not in Android Studio 3 or using the beta version of constraint layouts. Okay, some interesting fun facts. The way in which a constraint layout works is it's using what they call the Cassowary algorithm. And it's basically the same as what's used for iOS, as well as I think some web frameworks, but don't quote me on that because I'm not a web developer. Maybe Cassowary, I don't know. Okay, so basically what this is, it creates constraints. Your constraints on your views are expressed as a set of algorithms or equations that you create. And once I was just trying to find out exactly what the origin of it was, and the cassowary is actually a bird pictured here, and it's the deadliest bird on the planet, apparently. So it can kill you with its kick. So watch out for these birds. Okay, cool. So now I'm going to just go through. Okay, so full disclosure, I'm on a preview version of Android Studio, and I'm on a preview version of Constraint Layout. So if this goes wrong, we know what to blame. Okay, cool. So I'm just in Android Studio. I'm not sure if this is visible. Hopefully it is. But basically, there's a couple of things, and it's going to be quite daunting when you get to this design view. So the first thing to note is this little button in the corner, which is the design or blueprint mode. So what we have here is the design mode, and we have the blueprint mode next to it. So you can toggle between these two. So you can just view the design mode, the blueprint mode if you want, or you can do both at the same time. So what you would do typically is when you drag something on, so now we can drag elements onto our views. This was a hard thing to do before. So now I've got a view on the screen, but you'll notice that I've got this sort of like error next to my view. So this is saying that my view is not constrained at the moment, and I need to apply constraints to it, otherwise it will not render correctly when it runs on a device. So what I can do now is on the view itself, we get these, I think what they call, I'm not sure exactly what they're called, but they're called handles, yes. So you can click on one, and you can create a connection to something else or to the parent view itself. So I can just create a whole bunch of constraints. So these are creating left and right constraints. And now my view is constrained all the way around. So what you'll notice here as well is on this view, we have this sort of like detailed view of exactly what's going on. And here, you can control the sizing of the elements. So in this case, it's set to wrap content. So everything inside this button, if it's had smaller text, it would be a smaller size button. Or there's a minimum width on this one, but okay. Okay, so what I can do here is if I just click on these little elements here, I can toggle through the different size modes for an element. So now when I've got this sort of like squiggly line, it's called the match constraint. So that'll go and stretch all the way to the constraints that you have on the item itself. So that's set on the width, but I can also do the same thing on the height as well. So I can give it a fixed height of 48 dp, but I can also toggle and say I want the button to take up the whole screen as well. So that's match constraint as well. But we'll just stick it at wrap content for now. So interestingly on here as well is you'll get your default margins that are set. So with Android and material design, there's a whole bunch of guidelines around everything should have sort of 8 dp margins on all your elements, or 16 dps on a tablet, or there's a whole bunch of those sort of guidelines for you. So you can have, if you click on this button here, you can set your default margins that will always be added to every element. So in this case, it automatically added 8 dps to every single top, bottom, left, and right constraint. But I can easily change that to one of the other multiples if I want to. Okay, so there's also some other interesting tools on here. So you can also toggle the size of the device. So this was available before on the previous layout editor. But you can also, interestingly, drag to resize the device, if it will drag. No? Yeah. And then it will just resize to the different device that you've gone to. You can also do rotations, so pretty simple. So rotate to landscape if you want, and view it in landscape mode. What else is interesting up there? Okay, so one feature that's quite interesting is what we call auto-connect. So let me just change back down to a smaller size phone. So auto-connect basically says when I drag a view onto the screen, it's going to automatically connect and create the connections to whatever it can find that's close, that sort of makes sense. So it's kind of inferring and making its own sort of constraints as you go. So the button for that is this one over here, little magnet icon. I don't know if you can see that very well. But at the moment, I've got it turned off. And that's just for demonstration purposes. But if I enable this button, what I can do now is if I start dragging stuff on, you'll see it automatically added these two constraints onto my view itself. So I can drag on other ones now as well, and you'll see it starts to sort of add these constraints to it. So auto-connect just automatically creates these constraints for you. You can also clear a constraint by just clicking on it to delete it, and then it will sort of readjust where it needs to be. Another feature within here that you can use is what they call delete all constraints. So I'm not sure why you would want to do this, but maybe you would. But this just clears every single constraint that's on your buttons or whatever you've got on the screen. And now it sort of keeps the positioning information just within the layout editor. But if you had to run this on the phone, you wouldn't see, everything would just be all the way to the top of the screen. So it wouldn't constrain it how you see it over here. So interestingly, just to point out, is if you see, so these little tools tags that we've got here, so we've got a 62 dp tag for the absolute X and absolute Y positioning of this element. This is literally just for design purposes. And as soon as your view is constrained, those X and Y absolute values should disappear. See, now they're gone. So you won't have those, you shouldn't have those in your end layout that you have. It's just merely for your own positioning purposes. Okay, and then there's also another cool feature called inference. So if I have a whole bunch of things on screen, so I'm going to turn off autoconnect just so that you can see how this works, and delete that constraint. So I'll put some buttons on the screen, put a text view as well, and a radio button while we add it. Okay, so none of these views are constrained to anything. You can see there's no connections on anything, and we've got a little bit of errors over here as well. So if you press this sort of like magic wand, this icon has changed about 3 times since I've started using it, but this one is, it looks like a magic wand, but yeah, so if you press this button, it'll automatically try and figure out the constraints for that layout that you have on the screen. So now you can see it's created this constraints for the top button, and it's constrained this button to the other button, as well as, that's awkward, to the side of that one, but you can see what it does. So infer constraints just automatically takes whatever you have on your screen and tries to like infer what the screen should look like, or what the constraints should be. Cool, so we can delete all of those. Let's just delete them. Okay, so the next thing that I want to have a look at before I get there, let's just check. Okay, so there's another cool part that you can do with these constraints, and that is called a baseline constraint. So if I have a text view and I have a button, so say my button is actually got a height of 100 dp, I can constrain this text view's baseline to the button's baseline. So what that means is that the bottom of the text will align with the bottom of the text in the button itself. So what I can do to do this is you just click on the edit baseline view and you drag to the baseline of the button. And now you'll see, even though the button it's a larger size, it's aligning the text view with the button's text itself. Okay, let's get another view. Cool. So let's put another one on. So another thing that you can do is bias. So if I'm constraining something to the top and to the sides, there's a nice feature called bias where you can move something or bias something towards a certain direction. So you would just drag on the slider that's in the sort of sidebar, and then it's the element that you have is biased towards that one side. So if you try to achieve this kind of thing within relative layout or linear layout or something like that, it would be really difficult to achieve this kind of biasing of elements. Okay, now we get onto the more the newer stuff. Okay, so the next one that I want to show, which I think is quite cool, is what we call chains. So a chain is basically uses up elements of space with equal distribution. So if I grab all these elements and I right-click and say create horizontal chain, it chains these elements to one another. And now they are using equal distance apart, but there's also different chain modes that you can have. So I can cycle through these different chain modes quite easily by just pressing this little cycle mode. And there's 3 different modes at the moment. So there's packed, spread, and spread inside. So this is the packed version, so all the buttons are sort of packed together. And then we've got the spread, and then spread inside. So interestingly, you can do chains horizontally and vertically at the same time if you want. So if I wanted to do, for instance, another button, and I want a button there, but I want this one to align like that, and this one to align there, I can then take these 3 buttons and create a vertical chain as well. So you can see it can get pretty interesting, and you can do some crazy stuff. I don't know if I would ever use that, doing all those kind of chains. Yeah, but you can do it. Okay, cool. The next part, let's just delete these. Okay, so the next thing we can have a look at is what we call guidelines. So if you're developing or you've designed something in Photoshop or, I don't know, in any sort of design program, you would have probably created sort of guidelines or margins that you stick to, and these red lines are always on your screen, and you're always aligning stuff to these red lines. So you can create a guideline that does a similar thing. So what you would just do is right-click and select Add Vertical Guideline. You can also create horizontal ones if you want. And interestingly, it looks like nothing's happened, but if you look into the component tree down the side, you'll see there is a guideline element in your view tree. So now it starts to appear once you click on it, which is a little bit unintuitive. But what a guideline is now I can drag items onto the screen, and I can align things to this guideline. So instead of creating an 8 dp margin on every single element that we have, we can just set a 8 dp or 16 dp guideline and then align everything to that guideline. This also helps with developing for tablets or bigger size phones where you want the margins to be bigger. You can just change it in one place on the guideline itself, and it'll update everywhere on the screen. So we can align things to this guideline quite easily, and align things to that. And then as soon as we start moving it, you see all the elements move as well. So that's pretty nifty. There's also 3 different ways in which you can do a guideline. So this is currently just giving a 16 dp margin from the left or right. I'm really bad with left and right. But you can cycle between them. So if you click on this little icon at the top, you'll see it goes from the other side, and then we can set sort of a really big guideline from that side if you want. But you can also do a percentage of the screen, which I think is quite interesting. So this is probably hasn't been available for you if you wanted to do this without constraint layouts. So you can set it as a percentage of the screen as well. So if you have a really large screen, you can say 5% of the screen should be for the guideline. Okay, cool. So guidelines. Okay, so interestingly, just to quickly go into the XML, a guideline is just a view that's added within your XML layout. And your buttons and that just then, their constraints would then just align to this guideline. So if you wanted to do this kind of thing before using linear layouts or relative layouts, you would probably have to nest things and have everything have the same padding as the parent that it has. So you don't need to do that now, and there's no nesting involved with this. Okay, so the next one that we're going to have a look at is what we call a barrier. Okay, so we've got a clean slate. So what we can do with a barrier is we can have elements that are grouped together to form a barrier of where other things shouldn't be aligned to. And that was probably a really bad description, but hopefully you'll understand when I show you the power of it now. So if I have a button and I have a text view, so we have a text view on screen, and let's just align this so it's constrained. Okay, so we've got constrained, and this one is constrained to the top of that one. Okay, so we've got elements on the screen, but now the designer comes to us and says, all right, I want to put a text view here, or an image view here, but if this text view gets really big, I don't want this other text view to cut this text off, or if this button is bigger than the text, then the button shouldn't cut anything off. So what you can do now is create a barrier. So if I right-click again, and I can just say add a vertical barrier, and now also it's not visible on screen, but it's here, I promise. So now we have a barrier defined in our layout, but we can't really see it. So what you would do now is take these elements that you want to form the barrier and drag them into the barrier object there. Now, big thing to note is that this isn't creating a nested view like you would typically when you're doing other Android layouts. So this is just a normal view in your layout that has a bunch of referenced IDs on it. So it's not containing the view, so you're not nesting in this case. Okay, so I have a barrier, but it's still not showing up. So, well, it's there, it's very faint. But what I want to do is I want to set the barrier to be on the other side of the buttons and the button in the text view. Yay, right side, yeah. Okay, so now if I align something to it, so I'll put a button, and I'll align this button to the barrier. Okay, so we can just double check in our layout, and that is to the end of the barrier that we have here. So if I increase the size of this text, or the text multiplies, so it's really a lot of text, you'll see the button moves out and is controlled by that barrier. But if I just have something that's just a small text view, you'll see that it aligns to the end of the button and not the end of the text. So no overlapping for you. Cool. So that's barriers. And the next thing that we can look at is what we call groups. So groups are a little bit confusing because they kind of get you thinking of a view group in Android, but they're very different. So a group basically allows you to control a bunch of elements, and the only thing you can control at the moment is their visibility, so if they're visible or not on the screen. So it's a very simple layout, and I expect there to be a few more advancements to this one, but for the moment it just does a very simple task. So if I have a bunch of buttons on screen, I'm not going to create constraints because we don't really need them for this demo, but what I can do now is I can right click and say add group, and now I've also got this little mystical item in my view. But if I drag these 3 items into this view, you'll see now they're sort of in the view, but not in the same way as a view group. So we can check that again. They're just referenced IDs within my layout. So now on this group itself, I can just set the visibility of this whole thing. So I can set it to invisible, and all the elements in that group are gone, or invisible, or I can set them to gone, and all the elements in there are gone. So that's quite a nifty one, but not very feature rich. Yeah.
Can you do that from code though?
Can you do that from code? Yeah. You can if you want to. Okay, so the next thing we can have a look at, I've covered those ones, is dimensions. So if anyone's tried to create, for instance, a video player that needs to be a 16:9 ratio, yes, I've had to do that. It's quite difficult to do in Android. Delete, go away. So you would have to sort of either create your own custom layout and calculate the height of a screen and then do the width dynamically, and basically there's a lot of effort put into that. Or you can use like %layout, or there's a whole bunch of sort of layouts that solve that. But within ConstraintLayout itself, you can do percents without too much effort. So if I want to drag in, let's take an image for instance. So I've got a poster image. Can't tell that I worked at DSTV, hey? Okay, cool. So if I create a poster and I can set the height on this to, oh, that's really small. So, okay, so I've got a poster that's set at a certain height, but you can see the width of it is not really well calculated. So as soon as you constrain your view, so you can create constraints on the view. So this one's going to be a bit difficult, so I'll just press the plus there. Okay, so now I've got constraints on all my views. This one's added some padding, but I don't really want that, so I can delete it, just put it to 0. So on this view, when you change the size of the view, so at the moment the width of the item is set to wrap content, which doesn't really play well with constraints. So what you would probably want to do is set it to match constraints and not a fixed width either. So match constraints, okay? So now at the moment it's stretching to the whole view because I've got 2 constraints on each side. But what I actually want is this view to be a certain ratio. So I want it to be a 4:3 or a 3:2. So what I would do is just click on this little item in the corner here, this little triangular thing. It's very difficult to see. But basically what this allows you to do is then create a ratio constraint on this. So at the moment it's set to 1:1, but in this one I can set it to 3:2. No, it's 2:3. And then I have sort of a poster size image within my view. So that allows you to do, and then as soon as I increase say the height of my image, so now I want it to be 200 dp, the other width will be calculated automatically according to the ratio that we have. There's a lot more to ratios that I'm not going to be able to cover today, but you can do pretty crazy things using the ratios, so you can check that one out as well. Okay. And then lastly, something cool that I wanted to show. So this is something that I would love somebody to be able to try to do within a linear layout or something like that, because it could be quite difficult and you'd probably need to do it in code. So in this example, I have an image. So I've got a header image. And I'm just going to set the height of this one to 200 dps for now. And I will constrain it to the top, the bottom, and the side. Create a constraint there. Remove the padding. Okay, so I've got one image view on here. So what I want to try to do, I don't know if you saw the layout earlier, but I want to have a poster that's sort of centered on top of the bottom of this header image, we'll call it. So I can drag another image view on, and we'll put our poster back into it. And we'll set the height of this one as well. Okay. I'm just going to set this here. No, we'll do it properly. Okay, so we can create the, no, that's what I wanted to show. Okay, so at the moment, we want this to be to match constraints, and we want the layout of 2, 2, 3, or did I just do that one as well? Okay, so now I've got a poster and I've got a header, but I want this poster to be the center of this poster to be on the bottom of this image view. So what you can do is select the top constraint and say link it to the bottom of the poster. But then what you can also do is take the bottom and center it to the bottom of that one. And that creates what they call a center constraint. And if you've tried to achieve this kind of thing in programmatically or in any other kind of layout, you'll probably have a very difficult time doing that. So it's a really, really powerful tool in order to build sort of complex layouts that you might use. Okay, so I think I've covered from a demo point of view the stuff I wanted to cover. So we can get back to the sort of presentation mode. Okay, so we covered constraints, we covered baseline constraints, we covered bias, we covered chains, we covered guidelines, barriers, groups, dimensions. Cool, so now we get to the fun part. So when I started doing or looking into constraint layout quite a lot, I watched a lot of talks online, and I saw there's this really cool way in which you can start using constraint layout to create animations. So typically when you were creating animations before, it's quite complex. You need to make a whole set of animations and combine them and make this whole joint thing. And for me, it's just been really quite a pain to create. So with constraint layouts, it's a lot easier. I wouldn't say it's very elegant at the moment, but I see a lot of potential in this feature going forward in terms of there possibly being an animation tool where you can just drag and drop things within Android and say apply, and your layout animates for you. So that's where I sort of see this going. I hope it does, and I hope there's people listening on the internet, because that would be a really cool step forward. Okay, so how do we do it? So maybe I should show you the animation first, just so that we can see that. Okay, let's go to the emulator. Cool, everyone see that one. Okay, so I've created 2 different animations. So the first one is part of that movie screen that we have. So I've just made one where it increases the size of the poster view. I mean, why not? So that's the first one that I created. And the second one is a cupcake demo. So this one is basically also using the same concept that is applied in the previous one, but with a different layout. So you can create these sort of complex layout animations without too much trouble, with like 6 lines of code if you're lucky. So I'll just click that a few more times just because it's really good. Cool. So how do we do this? So basically what you're going to have to do is in your project, you'll have to sort of create 2 layouts. And this is where the sort of con comes in at the moment, in that you're duplicating your layouts, which if you now want to maintain them, you've got to maintain 2 places. But I mean, it's a really cool feature, so you don't really mind. Okay, so we've got our first layout that we've created. But then what I did was you basically just duplicate the layout and then make the changes to the constraints that you want. So in this case, I created a new layout and then just increased the size of this poster to a bigger size. And I also, I think, hid one of the buttons that were there, and I think I made a bit of the text a bit bigger, or I don't know. It was just basically the size of the poster was bigger. And then basically all we needed to do from that point on is in code itself. So this you have to code. Unfortunately, you can't do this in XML. But we would have 2 constraint sets. So the first constraint set is going to contain the current layout that we have, and the second constraint layout set, or constraint set, not constraint layout set, constraint set is going to contain the layout that we want to get to. So we would create these 2 objects. This is Kotlin code if it looks a bit confusing. First time I'm using Kotlin in the presentation, yay. Slow clap, yeah. So the next step that you would need to do is in the second constraint in the constraint set, you would clone the layout that you wanted to go to. So in this case, I'm going to the large layout that I have. And then I would just clone the layout that's currently visible to users. So this is just a view that we have defined in the screen, so the whole view of the whole screen. And then all we need to do is apply the transition between the two. So this constraint set 2.apply to with a different constraint set, or the different the layout that you want it to apply to. And then you can add a sort of slow transition, so a bit of a delay to it, so that it gives you that sort of animation effect. And that's how you can create these sort of complex layout animations without too much trouble. Cupcakes. Cool. So there are some caveats with this, in that you can't animate things such as, so if you change the color of the text, it's not going to animate that change because it is only applying the new constraints. So if it's something of the view size, it'll automatically animate that, but it won't animate things such as text color changing, or for instance, in this case, I tried to change the scale type of the image view, and that didn't work because it doesn't know to animate the scale type, because that is a property defined on the image view itself and not within the constraint layout set. But I do see this going forward as probably one of the ways in which animations will be created in your layouts. Yeah?
So because you're just changing the constraints, do the components have to stay the same?
Yes.
Able to add or remove?
I haven't actually tried that, but I would assume that it needs to remain the same. But yeah, we should try that. Okay, so we're going to step back a little bit from constraint layout and look at a little bit about performance things that you can do within your layouts and where problems would occur within your layout, so that you know what to look for in your views. So in Android, and probably in a few other places, what we have to do is make sure our frames are rendered within the 16 millisecond frame mark. So this is because the human eye can only needs to process 60 frames per second, and if you divide that per frame, it's 16 milliseconds. So basically, when you're rendering something on the screen, you need to be able to render it within that time, which is a very short amount of time if you look at exactly start doing things within the layout. So things that can typically cause problems within your layout, the first one I've mentioned before is if you have deep hierarchies. So you shouldn't have this if you're using constraint layouts. If you're nesting things in constraint layouts, you've probably done something wrong, and you can go back and have a look and say, what have I done wrong? Why am I nesting this? It shouldn't be done like this. So this is only when you're probably doing like linear layouts and relative layouts and those kind of layouts within there, then you'd get deep nesting. So that can cause some problems. And say, for instance, now one of your views in your screen needs to change its size or position. So what it has to do now on your system is it has to go and redraw and the whole layout. So it has to go through the whole layout process again. So that can be quite problematic as well. So another problem is that some layouts need to do multiple layout passes. So like I mentioned before, relative layout needs to do multiple layout passes, as well as if you're doing weights on a linear layout. So that's why I said don't do weights if you can avoid it. Interestingly, if you look at constraint layouts, if you're doing things such as a match constraint, sometimes it does need to do 2 layout passes in order for it to render on the screen, because it needs to sort of measure out where its other views are and where it's constrained to. But there are a lot of optimizations within constraint layout in order to make sure that there's very little of that being done. So it does happen, but not as often as relative layout or linear layout. Okay, and then also when you start to put things in a list. So if you have a recycler view or a list view, and you're putting a layout that's a really deep nested layout, and now you're duplicating that with 100 elements on your screen, then you can start to see a lot of performance problems as well. So you probably want to be flattening your layouts as much as possible, even if you're putting them in a recycler view or a list view. Okay, so some tools that you can use within Android Studio and the Android Device Monitor to profile your layouts. There's a lot of tools. I'll just touch very briefly on some of them. The first one is Hierarchy Viewer. So this one allows you to take your layout that you've got visible to the screen, so it's running on the emulator, and you can profile your layout from here. So you can view exactly what's on the screen and the size and positioning information of it. And you can also run the layout process again on it. So if you see on this, I've got these 3 little dots on a view. So I've got a barrier, I've got a button here. So these 3 dots indicate the different process parts of your layout process. So in this example, we have the layout, the measure, layout, and draw. And that'll tell you, if you see on this one, it's probably very small, but you can see the millisecond measure of how long it actually took to render that element and its children that it contains. So you might see some red dots happening here. If you profile your layout, that generally means you should have a look into it, why it's not performing very well. Okay, the next one is the layout inspector. So this one is very similar to the hierarchy viewer, but this one is in Android Studio. So my gut feeling is that this one is going to be the one going forward, but it doesn't have all the features that hierarchy viewer has right now. So hierarchy viewer has all the profiling stuff, whereas this layout inspector only has certain information. So it'll tell you exactly where it's positioned on the screen and how the sizes and the calculated stuff on the screen. So you'd have to, in order to profile it, you'd probably have to go back to hierarchy viewer. Okay, so this one is also a cool one, but this one runs on your phone. So this is GPU Overdraw. And if you go into the developer options on your device, you can select debug GPU Overdraw, and it'll start to make your screen a completely different color, if you can see in this example here. And basically what it is telling you how many times that pixel has been redrawn on the screen. So generally you want to avoid redrawing as much as possible, and you probably want to have as like 1 times overdraw or no overdraw if you can. But you can see if it's red, it means that there's been a 4 times overdraw on the same spot. So in this example here is an app that I work on called BookDash. And this one has, basically you can see there's a lot of overdraw happening. And the fix for this was actually pretty simple in that it was just a background that was set on the whole view. So when you're developing in Android and you set a background on a view, on a whole layout, you've got to remember that the Android system itself and the theme of your app has a background itself set on it. So initially in this layout, you might think, why is it drawing 4 times? But what was happening is I had a white background set as my theme. And then on this layout, I set a grayish background on top of that. So it's drawn twice now already. And then I had the card view on top of that. So that's number 3. And then on top of that, I had the images. So that's 4 times I've drawn on the same pixel for this little view. So a fix in order to make it less amount of overdraw was to literally just remove the background color on the view and set it on the whole app theme itself. And then I had a much more performant layout. Okay, another one is profile GPU rendering. So this one's also available on your device. And what this one does is it just shows you exactly how well your layouts are performing as you're going through your app. So if you turn this one on, you'll start to see a graph being drawn on your screen. And this one just shows you the little green line at the bottom here just is the 16 millisecond mark. And if you're scrolling through your screen, you'll see some layouts just go over that completely. And that is an indication to you that this frame is taking too long to draw. So you should probably investigate this screen a little bit more and see exactly why this layout isn't performing well. Okay, so in summary, all I can say is that you should really, really start to use ConstraintLayout. I know there's been a little bit of bugs before, but really, if you look at Android Studio 3 and all the new features, it's a really powerful layout to use, and it solves a lot of complex problems that you would have had to manually do yourself. So if you want to find out more, there's a link to the docs at the bottom, and there's also a ConstraintLayout code lab if you want to try out the features yourself as well. Thank you. Yeah.
The code labs are written in Polymer.
That wasn't a question. Yeah.
Cool. So I had 3 questions and he's still 1. But my first question is, can you do tablet layouts at the same time? So you have your constraint layouts, whatever,
Yeah.
and then do you still have to do the whole size folder things and then copy it over and do the constraints in there? Or can you not just use just change the constraints?
Yeah.
Since you can drag it like that.
So you can. So it's difficult because it's dependent on what you're doing. You would probably still need to, in some cases, create separate layouts for separate devices, like for a tablet, if it was really different. But what I try to do is just make sort of the size of views and the the padding and the margins different on different size devices. So that at least you have one layout and it's just the size of the views and the margins that are different. But you can also programmatically change the constraints as well if you do get to that level. Hopefully you won't be doing that, but yeah, you would. It depends on the case of what exactly you're trying to implement. Don't know if that answers your question. Probably not.
Not really. understand. And then, well, my second one, I think you can use for, I think, the centering thing. Can you not use coordinated layouts for that with anchors?
Yes, so
anchor the thing to the center and then they just stay there.
Yeah, so what I was trying to achieve with this was, so the Google Play Movies app, if you have a look at it, it is using coordinator layout because the actual header at the top like sort of does a sort of parallax effect and scrolls off the screen at a different rate to the rest of the view. The aim of what I was trying to do was literally just to recreate it within ConstraintLayout to see how much of it I could recreate with it. But yes, you can use anchors in that, but if you've tried to work with coordinator layouts, it's really horrible to work with. So I would prefer to do it this way, but it's not the exact same solution to that. Cool. Yeah, there was one more. Yeah.
Is like groups and barriers, guidelines, those things updatable from code?
Yes. Yeah. So they're just normal sort of views. They're like imaginary views that you can access and change and add things to. Yeah.
And the second question is, can you use negative margins?
I haven't actually tried, but I would assume you can. I don't know if you should. Negative margins are always a sign of something not right. But I'm sure you could. I haven't tried it though. Yeah.
I haven't done Android in a while, but from last I remember, when you included that image, and you could actually size it according to the DPS, the device DPS.
Yeah.
Do you still need to include like image for a large device, small, medium?
Yeah, so what you would typically need to do, in this case I've just used one image because it was easier, but you would probably need to resize it based on the density of the device. So if you're getting it from a server, you don't want to download a high-res image on a really low-end Android device. So you would need to still scale it down to the correct size for the device. It doesn't do that for you. Cool. Is that it? All right. Thanks.